Okay, page 32. I don't know if you want, or it's important to you or not, but 20 questions, 48 points. All right, somewhere on page 32, you might want to make a note. I didn't write it on there, along with all the other theorems we've learned in this, but make sure you're familiar with the auxiliary lines, because I may give you a problem tomorrow where you're not going to be able to find what I'm looking for unless you draw in your own line that'll help you out. All right, so look back. There's one example definitely in your packet, and I believe we did another one for homework that night. So make sure you're familiar with auxiliary lines tomorrow. Okay, what else going into tomorrow? There's some other things I need you to jot down that I did not write in that review sheet there. Make sure you are aware of the two different equations, one for a vertical line and one for a horizontal line. All right, one for a vertical line, equation for a horizontal line. While you're writing that down, let me ask you, anybody remember a vertical line? What axes does a vertical line always go through? The X or the Y axis? X. So that tells me that any vertical line I have to write the equation of will always start with X equals some number. And anybody want to give me the slope of a vertical line? Undefined or no slope, yes. All right, horizontal line will go through what axes? The y-axis. So this will always have the equation y equals some number. And what about its slope? Any horizontal line will have a slope equal to 0. Yep. Also add in under graphing, make sure you know the slopes of parallel and perpendicular lines and how they relate. Slopes of parallel lines are what? If you have two lines that are parallel, you know, what about their slopes? Equal, yep. And how about two perpendicular lines? The slopes are negative reciprocals. Constructions, I told you one of them out of the two will be on there tomorrow. And I will let you know the two proofs that I'm going to tell you the two proofs that are on there. First proof is I'm going to ask you to prove parallel lines. Second proof is going to involve those three theorems on your index card somehow. And you are not allowed to have them. Am I looking for word for word exactness? Nope, but I'm hopefully you'll be in the ballpark. Okay, so those are the two proofs. Somebody asked me in the second period class, do we have to know all three of these? And my answer was no. I will tell you anything I need answered tomorrow should be left in slope-intercept form. Should be left in slope-intercept form. That does not mean, though, that I can't give you an equation in standard form and ask you to pull the slope off of it. Okay, don't disregard standard form and point slope. I'm just saying to you guys, if I want you to write an equation of a line for me, I will ask that it be in slope-intercept form at the end. But I could always give you an equation in standard form and point slope and ask questions off of it. Anything you want to ask there? We need to go over proofs, obviously. All right, so I'm going to do two of the proofs in your handout with you. And then I'll see where we are, how I feel, and I'll let you go. Question? Okay. Everyone got an assignment sheet as you came in? If you didn't, there's not much to tell you about it. We got the test tomorrow, and we start the new unit Wednesday. All right, so here we go. I'm going to do the first proof. I'll give you a chance to set it up, look at it. There are two things I'm asking you to prove here. They are not two. This is one proof. It's just going to be one proof. We'll prove the first one and then continue the proof to prove the second one. Okay, here we go. First thing we need to prove, show me BF and CE are parallel. Show me those are two parallel lines based off of these two givens. So when I give you these two givens about perpendicular lines, anything going through your head right now, I'm going to call on somebody because this could go a lot of different ways. It could go a lot of different ways, this proof. But when you see those two givens, anything come into your mind? Let's hear from 21. Why? That's what I figured some of you would think about. Maybe you're not, but that's fine. But take a look. Two perpendicular statements, both perpendicular to the same line, meaning they are parallel to each other. BF parallel to CE. And somebody else, I don't know if you heard Marin or not, but 5, what's the reason I want to use for this then? Yep. That's right on the index card, one of them anyway. 2 lines perpendicular to the same line. Okay, I want everybody to stop because I want to show you the other way we could have gotten them parallel. If maybe you just didn't see that. You didn't apply that index card to it. You just didn't see it. Fine. Perpendicular lines form what? 90-degree right angle. So I have a right angle here and a right angle here. Or you could have chose the other two. Doesn't matter. Everyone see the 2 right angles. Definition of perpendicular lines. What do you know about 2 right angles? 22. What do I know about 2 right angles? They're equal. These 2 angles not only are right angles, but they're equal. Okay, we've discussed a lot in detail in this unit. What type of angles are those 2? Because they are special. 18, know what type of angles these 2 are. And they're congruent. Put them both together, everyone. If I have corresponding angles that are congruent, that forms what? Parallel lines. So that's the other way I've got them parallel. Let's say congruent corresponding angles. All right, that's done. Now, can you get PFB congruent to, let me highlight them. Let's see, PFB congruent to QCE. You got to start approaching it this way. First thing I'm going to ask somebody is, do they share a common line? 17, do they share a common line? They don't? Name it? PQ. Everyone see PQ. And hey, what are the other 2 sides? The darn parallel lines we just proved. So they have to have some relationship. If they have a line in common, PQ, and the other sides are the parallel lines, they have to be some type of angles. And that's what I'm going to ask you for now. I'm not saying they're congruent yet. I'm just showing you so you can visually see it. What type of angles are those 2? Look where they are. 10. Alternate exterior. Thank you. They're alternate exterior. And if those lines are already parallel, that must mean they are indeed congruent. And I'm going to look for somebody else to finish this proof. What would be a great reason to use here? 18, great reason to use. Okay, I don't mean to cut you off there. Can we please have that tomorrow? because they're not congruent unless you have parallel lines. Go ahead, continue. Perfect. Yes. 3 steps. Could have been longer depending on how you looked at it. Absolutely. But this is about it. This is as short it could be. We good there on this one? Proving parallel lines and then using that to show the alternate exterior angles. Proof 3 now. Proof 3, everybody. Go ahead, get set up with proof number 3. Much different than the one we just went over. How many of the givens will you use? All of them. Okay, let's keep that in mind in this proof. Because I'm asking you to prove A congruent to B. And if you look at A and B right now, let me highlight them. I 100% agree they have a line in common, right? AB. But what about the other two sides? Are they parallel? Are the other two sides parallel? So they have no relationship. Don't try to force it. Plus, you know, you're going to have to use your givens here, which you haven't if it's a 2-step proof. All right, A and B have zero relationship. Okay, I'm going to start with the parallel lines first. Can you please get me a pair of angles that are formed by CE, AB, and a common transversal? Please, please. 2 angles formed by CE and AB combined with a transversal, common one. 9, you're up. Say that again. B and ECB. I like it. That's a good pair right there. Angle B congruent to ECB. They both share CB as their transversal, and they're formed by CE and AB. Nice job. Going to need somebody to first tell me what type of angles he just gave us. 2, what type of angles did he just give us? And B. Okay, alternate interior angle. So give me a good reason now. Number 8.
Parallel lines imply alternate interior angles.
Perfect. Got it. There's another pair up there. There is another pair other than those alternate interiors, which we are going to need. Find them. Find them. Now look, we just said something about angle B. What's the other angle in the proof statement? A. So we might want to say something about angle A. All right, there's a hint. We may need to say something about angle A here and introduce it into the proof. 13, anything with angle A and any other angle? Yep. DC, ECB for this angle? Okay. Okay, hold on. I got angle A done. You're saying it's congruent to which angle? D. So here you go. Let me make sure I got this right. This angle and angle A. Got it. Because that is correct. What angles were just given to us? What type of angles? 20, what type of angles? Corresponding. Nice job. So give me a good reason right now. 7, give me a good reason. Thank you. Can you go right to say A is congruent to B from these two statements? No, this is not substitution. Plus, we haven't used the given yet, have we? What given have we not used? 20. Which given have I not touched? Yep, that DCB is getting bisected by CE. What two angles now are congruent if that's true? 5. What two angles are going to be congruent? Good. DCE congruent to ECB. Good reason why? 9. Good reason why? There we go. All right, we had a little trouble with this on the quiz. This is why I'm doing it again. Do you see how you have 3 congruent statements here? Can you just pick 2 of them and get A and B congruent? Let me ask you if you can do that or not. Out of those 3 congruent statements, can anybody just take 2 and get A congruent to B? If you're shaking your head no, then you just can't substitute once and get A congruent to B, because you're telling me there's no way you can get A congruent to B out of any of these. But please pick 2 of them right now that I can use substitution on. Number 7, pick 2 of them I can use substitution on. So you're taking these 2 right now. Okay, please perform. I know he said it already, but number 10, perform substitution on that. What 2 angles are equal? Yep. Angle B congruent to angle DCE. That's the first substitution we did. And now somebody perform a substitution on steps 3 and 5 for me. 8, what 2 angles are equal when you do substitution on 3 and 5? There you go. That's what I needed. A second substitution. Now, I don't know, just let me talk about this quickly before I let you go. I don't know if anybody, saw this and started having a little halves of equal quantities love there. How many angles are getting cut in half? Just one. Remember, you need two to use halves of equal quantities, not one. Now, could this proof be done in a different order? Absolutely. I could have done bisector first. Any of these could have been in a different order. And then your 2 substitutions at the end. Any other questions there? Okay, top of that page on page 33, I've recommended some textbook questions for you if you want to try those out now or tonight. You also have a couple other proofs on the front and the back. And then if you look at the back of your packet, I have my versions of the proofs. If you have a different version and want me to check it, I will be more than happy to. All right, these are just my versions of the proofs. Okay, let's get to it. You go textbook or you can keep